Good morning. This is Miss Billerbeck, and we're going to talk about 6.4 enlargements and similarity. So if we have a scale factor and it's the length of an image side over a length of an object side, then if we have two similar triangles like this, we see that if we put the image side over the corresponding object side, and we do that for every single side, we get a scale factor of 2, because 8 over 4 is 2, 10 over 5 is 2, 14 over 7 is 2. So this is called an expansion when we have a scale factor greater than 1. We have an expansion. So this scale factor is 2. Now, if I have a circle and then it gets much smaller, and I have a radius here of 7 units and a radius of 1 unit, then this is a reduction of a scale factor of 1 over 7. So the image goes over the object. So here's my image, here's my object, so 1 over 7. So if we're given an object like this and they ask us, find the scale factor. Well, okay. So what we could do really quickly is we could say, oh, that's not so hard. Okay. Because look at this. We have 1 here and we have 2 here. Well, that's a giveaway. So we could just say, well, that's going to be a scale factor of 2. Okay. So if we took this and actually used tracing paper to do it, and I wonder if it would even copy on there. But if you took this with tracing paper, you would see that it'd probably line up pretty nicely in there as a scale 1 to 2. But there's another way we could see the scale factor of 1 to 2. Okay, so we can count here. We have 1, 2, 3, 4. So 2, 3, 4, 5. And then if we count here, we have 2, 4, 6, 8, 10. Ooh, so the width. So we don't necessarily, since these are really hard to figure out, we could just find this width right here, which is 5. And this width here is 10. So I'm teaching you the easy way to do it, by the way. So it's 10. So we have a reduction going on. Okay, what about, we could look at the height. If we didn't want to deal with all the distance formula and all that to figure out these, we could look at the overall height. So if we count 1, 2, 3, 4, 5, 6, I've got 6 here. I would expect that I probably have 12 here. So if we're looking at this, we have 2, 4, 6, 8, 10, 12. So I do have 12 going on here. Okay, so you don't always have to find every single side. Okay, you could do it the smart way. Okay, so now we can see if we make this proportional and we write things down. We have 1, we know that's the corresponding side over the object side is 2, and then the overall height was 6 over the overall height of 12, and the overall width was 5 over the overall width of this is 10. And one last thing we should probably check is, where is this point? So that point ends up, it's 2 above this line, and it's 4 above that line, and that would make sense because our scale factor is 1/2. Okay, so that's how you could figure out scale factor very quickly. So normally we think of enlargements as something that's getting larger, bigger. Okay, but in the definition, a transformation that produces an image of the same size but same shape, same shape but a different size. Oh, so that means it could get smaller, but it's still called an enlargement. Okay, so it is either expanded or contracted. So expanded or contracted, expanded or reduced. Okay, so a scale factor is, we always want to keep the image on top, the image length, and the object length down below. And that would still equal the distance of the image from the COE, which is center of enlargement. So the distance of the image from the center of enlargement over the distance of the object from the center of enlargement. You may say, hold on there, we don't know what a center of enlargement is. Well, let's find out. Okay, let me share the screen. All right, so if we have a center of enlargement here, and I have two objects, how we find that center of enlargement is we go from a corresponding side here, and we go to the corresponding point there. We go from the corresponding side here, and we go to that corresponding point here. We can go from this corresponding point here and that corresponding point here, and then we start going, wait a second, are all these going to go through that one point? That's pretty crazy. Well, wait a second, don't we do that in art when we're enlarging something and doing a perspective drawing? Wow, that's the center of enlargement, this point right here. And it really doesn't matter if I ended up moving the shape or anything. It's just where do all those the lines of the course from the corresponding points, where do they all meet? And that's called the center of enlargement. Okay. Back to this. Okay, so an enlargement with a positive scale factor has a similar image to the object. Okay, as has the image length k times the length of the object, and the object and corresponding image points lie on the line intersecting the center of enlargement. So we just saw that we made this line and all the corresponding points lied on a line that intersected the center of enlargement. Okay, so that was kind of cool. Okay, so also we have the object and image on the same side of the center of enlargement. So the object and the image are on the same side. Okay, so we also saw that. So that happens with a positive scale factor. So we can infer from this that if it's a negative scale factor, then that object's on the other side of the center point. Okay, so there we have it. So those are some general rules that we have with enlargements. Let's do an example. Okay, so we have L, M prime, N prime. So that's obviously our image because we have primes, okay? Is the image of LMN, okay, triangle LMN. What is the center of enlargement? Well, that's kind of easy, look. So if that's a corresponding point to that, and we draw a line, and if that's a corresponding point to that and we draw a line, look, it just meets at L. So it's just 1, 1. Okay, so we can write that the center of enlargement is just 1, 1. Well, what's the scale factor? Okay, well, that's going to be an interesting one. What is the scale factor? So if we look at this, we can look at, okay, so that looks like it's hitting at the midpoint. And that's hitting at the midpoint. If we count how many spots here we need to go to get to here. So 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. It looks like we've got a midpoint here. Okay, if that's true, then this side is twice that side. Okay, so that would mean this side is twice the length of that side. All right, we could do the distance formula. I know it's not something that you like to know about, but we could do the distance formula too on this one. But I don't think you've learned the distance formula, so we won't do it. So we will just use our keen sense of strategic logic, and we will say that this is twice that. So our scale factor, since the object is twice, it goes down below, and the image is 1, so we put a 1 there. So the type of enlargement, it is a reduction. All right, so let's take a look at this example. Okay, so we want to transform triangle ABC clockwise 90 degrees, but hold on, it's not about this origin here, so that means that, these don't work, these rotation rules don't work because we're not rotating around the origin. Okay, so these were rotations around the origin, which I probably should have marked. Okay, so we have to go from 1, 1, 0, which we're rotating from here. Okay, so if that's true and we're rotating clockwise 90 degrees, which is this direction, then my new point A is going to be right here, because that would make a nice little 90-degree angle. Okay, you see that 90-degree angle right there? That's 90 degrees. Okay, so if I count this one, then this is also going to be at 6 right here. So let's make sure I've got it right, 2, 4, 6. So actually it's going to be right here, because we are starting at 1, 0. Okay, actually it's not even there. We're moving. So if we move 1, 2, 3, 4, we have to move 4 from here. 1, 2, 3, 4 right there. So we have to be very careful because it's an unusual situation. Okay, so that means that we have our one side right here. Okay, but it's rotating down, so that means this point here that rotates here, and now we have a rotated figure. Now, in a perfect world, I would have just used my straight edge and not relied on my almost keen sense of making a straight line without a straight edge, but that didn't work very well. So you can tell I didn't use a straight edge, so you probably should use a straight edge. So if I can't draw a nice triangle without a straight edge, maybe you shouldn't try either. Okay, so now we want to enlarge triangle ABC A prime, B prime, C prime. So here's A prime, B prime, C prime. So that means you are not going to be enlarging the original triangle. It says enlarge the image of the original triangle. So about 3 and negative 2. Okay, so let's find where 3, negative 2 is. Okay, so we're at 1. Here's 2, here's 3. 3, negative 2. So now it says enlarge by a scale factor of 2. Okay, let's see what's going to happen. So we know it's on the same side. So it's going to be on this side. So we're going to go, oops, let's see. So we'll make a line right here, connecting the center with this. Let's see, there we go, finally got it. Okay. And our last one's going to be right here. Okay, so if we're enlarging by a scale factor of 2, then that means that we're going to be on the same, this somehow goes on to the same one here. So I am going to have to say this is going to double here. So if we count 1, 2, 3, 4, we count 1, 2, 3, 4. So we have a new point here, which means we have a new point here. Let's make sure I did that 1, 2, 3. So it'd be right here because my line's just a little off. So a new point right there. And that means that my new point is right here. So if this is 1, 2, 3, 4 is right here. So I have an enlargement that looks like this. For you artists, this must be just a fabulous lesson. Oops. Okay, so my enlarged triangle here, let me just dabble these little lines so they're not confused with the other line. Okay. Okay, so we have our new figure, A double prime, B double prime, C double prime. So this figure, this shape right here, is enlarged or expanded by a factor of 2 from this point at 3, negative 2. All right, well, that's it for our lessons for enlargements and similarity. Have a wonderful day.